Okay, welcome back. So at this point, we've taken a look at creating our bounce code so that we can have a whole bunch of buttons bounce around a screen, and it looks good. We've then moved on to the creation of our random sequence generator. That worked out nice for us. At this point, it's time to take a look at audio. How do we go about getting sound into our games? Now, we have not dealt with sound at all in the XNA Xtreme class so far, that we've had no sound in Canon Project or Precision or Hyperion or anything else we've done. So we need to take a second and kind of back up and talk about the tool that is going to enable us to get sound in through the content pipeline and into the world of XNA and for our games to be able to use it. And this is the Microsoft Cross-Platform Audio Creation Tool, commonly referred to as Exact. That's what we're going to be taking a look at. So we can't just come in right here in Visual Studio Express and right-click and say, content pipeline, let's add this in, and there's an audio file, and woo! It's a little bit more involved than that. Now, this is just an introduction to getting sound into your game. This could very easily be a very deep lesson because there's a lot involved once you get over into the Exact tool that we're not going to be covering. Please keep that in mind. The idea is just how do you go about getting audio into your project, and then how do you have that audio play in your game when you want it to play. So the tool we're going to be looking at is Exact. Where do we get to it? Well, the tool has been installed automatically when you install the XNA Game Studio Express. So if we come over here to Start, we come up to Programs, and we come over here to Microsoft XNA Game Studio Express. Let's go to Tools, and there's Exact, the Microsoft Cross-Platform Audio Creation Tool, Exact. We'll go ahead and click on that, and the tool will launch. Bunch of different things going on here because there's a lot of different things that we can control in regards to our sounds and the way those sounds work when we get over into our XNA game. Right, Logan?
Right. As a matter of fact, there's actually it's more of a full processing engine, meaning that Exact will set up a project that can handle things like sounds being positioned in 3D space, sounds that will attenuate as they get farther away from the player, and even control things like the Doppler effect of pitch changing as a moving object goes past the player.
Exactly. But our focus here is just how do we get a sound set up so that over in our game we can play that sound. Now, you'll notice that the layout here is similar to a lot of the different Microsoft development environments where we've got, basically a working window here, document area, if you will, properties, menu bar, etc. We're not going to be getting into most of these things. The primary focus is going to be on the creation and use of wave banks, sound banks, and cues. Okay? Now, Logan, take it over. Where do you want to go?
All right, well, we should begin with wave banks because a wave bank in Exact is how you import the wave data itself. It's how you import wave files and get the original source audio data. So what we'll do is we'll create a new wave bank by right-clicking on wave banks. And this area will allow us to load in wave files in order to populate this wave bank. Now, I have some wave files over here in our working folder, but I want to move these over to our project before I actually move them into Exact.
Just in case we happen to take our entire project and go mobile with it,
right,
everything goes with us.
What's going to end up happening is the Visual Studio itself, the XNA content pipeline, is going to actually have to look at these wave files at some point, which means that it would make our project dependent on this working folder. It would be more convenient for us if we had all of our files in a single project. That way, if that project was ever moved, all of the source content is still there.
Exactly.
So in order to do that, I want to establish a sounds folder inside of our project structure, and I'll actually do that from within Visual Studio itself. So here is our sequence test project, and I'll go up to the solution, add in a new folder, and we'll call this folder Sounds. Now if we look at that project folder over in Windows, under Sequence Test, we can see that has indeed created a Sounds folder. So I'll grab our sounds from the working folder and move them over to the project folder. Now that I have their sounds in what I'll call their final resting place before build, we can now take these sounds and import them into Exact. So let me bring up Exact, bring this folder back up, and simply drag and drop the wave files into our wave bank.
Okay, just a real quick note about these wave files. They were generated over inside of SoundForge in about, 3 minutes maybe, so nothing fancy. You're more than welcome to go and get some sort of keyboard or some other device to generate some really great sounding sounds. But hey, no laughing. This gets the point across.
All right. So
before we really go much further, one of the things that people are probably going to want to be able to do is to preview these sounds while working in Exact. So let's go ahead and show them how
Especially
they go
in this
about
case
that.
where beep 1 through 4 doesn't necessarily describe why one beep is different from another.
Exactly.
So let's take a look at what we would need to do to preview these. If we click on any of these waves, we can see that we have a play button, but that won't be playable directly from within Exact itself. Exact will process the data, but it won't actually output it. We need to load the auditioning tool before Exact will be able to actually play the wave files. And the auditioning tool is located under the same menu as Exact itself. Directly below it we have the Exact auditioning utility. And this acts as an output service so that Exact can connect into it and actually display the audio data. So with this tool loaded, we could go back to our wave bank, select any of the waves, hit play, and now it'll connect, synchronize, and then play that sound. So we could go through and see what all of the different sounds are sounding like.
Okay.
But just keep that in mind that you have to have the auditioning tool open before you can play audio files from inside of Exact.
Now at this point we have our raw data dumped into a wave bank, but we're not yet ready to process this through and access it from our game.
Right, and that could be a little bit confusing at first because we could save this project if we wanted to. So we could come back to later and work on it some more. And the project would be allowed to be loaded into the content pipeline inside of Visual Studio, and everything would look like it works until we try to start playing things. And we wouldn't be able to play any of the sounds yet, and that's because the tools given to you inside of XNA work on Q files. We mentioned those briefly earlier, but we haven't gotten to them yet. We have to look at sound banks and then Q files.
Okay. So let's go ahead and establish a sound bank. Let's go and create one.
All right, so we'll go over to Sound Banks, right-click on it, and say New Sound Bank. And Sound Bank is divided up into two areas. We have sounds and cues. A sound describes the properties of a wave. It describes how wave data should be used to play an actual sound. And it actually supports more than one sound at a time. You can actually layer tracks together, layer sounds together in tracks, if you want them to play over themselves. But we're going to keep it simple. We're just going to focus on playing a single sound.
Meaning if we had like an explosion sound, then we could have the explosion, we could have some crackling, we could have what sounds like, pieces hitting the ground, and then in the sound we could layer all of these different waves together from the wave bank and then have this final sound.
Exactly, and have the Exact audio engine render them all as a combined mix.
Precisely.
But what we're interested in is just getting a simple sound loaded. And the most basic way of doing that is to go to the sound pane, right-click, and say New Sound. This creates a new empty sound with no wave data associated with it. Now, if we want to do this the complete manual way, we have to add a track to the sound, which you can do by going to the right pane and saying New Track, and then dragging some wave file onto that track. So let's grab beep 1 and drop it onto track 1. This will drop it a play wave, give access to the beep, and is showing it at 100%. It also allows us to set some of the properties for the wave itself. If we go back over to the sound, now we can set things like volume and pitch.
Okay.
Now,
go ahead. I was going to do exactly what I was about to say. You could right-click and add another track.
And then we could add another sound to it. And now if we play that whole sound...
So now we got both of them.
Playing at the same time.
Exactly.
So that's all very cool if you want to do some more advanced sound mixing, but what we're interested in is simply getting one sound put in. And if that's all you want, if you just want to get one wave as a playable sound, you could take a quicker route and just drag the wave itself into the sound pane.
Also, go ahead and point out before we move on from new sound that over on the left-hand side in the properties window area, you can go ahead and set the name as well.
So we could say maybe 2 beeps.
Okay, simple enough. So let's go ahead and kill that sound out.
All right, I'll kill this one out. We could right-click or just press the delete key, and then that will remove it from the project.
All right, so now let's just make beep 1 easily.
So if we know that we only want beep 1 as a usable sound, we could take that wave and drag it directly into the sound pane, drop it, and we get a sound named beep 1 based on the wave with a track automatically created.
Okay.
So very convenient if you want to get things set up quickly.
But we're still not ready.
No, we're still not ready. We have described how we want to use this wave to make a sound, but we have not set up a cue for that. That is not how and when it should play. So a cue file is going to describe what should happen when you actually want to play a sound, because a cue can do a few advanced things of its own, including controlling multiple sounds and setting them up to where they play in sequence or play at random. So if we wanted to create a queue manually, we could go down to the queue pane, right-click, and say New Queue. And of course, we could name it if we want. Now, we need to associate sounds with this queue, which we do by grabbing sounds from the sound pane, dragging them down by the icon, and dropping them onto the icon of the queue we desire. So if we drop beep 1 onto new queue, we see it appear in the right pane as beep 1 with a play probability of 100%. And it's 100% here because with the random jumping it's trying to do, it has only 1.
Which is what he's talking about. Actually, you can show that over there in the queue properties. So at the bottom, playlist type random with no immediate repeats. So a minute ago we talked about we could have a sound that is called explosion. In fact, let's call it explosion 1, and inside it there's maybe 4 different tracks that make up that particular explosion. Then we could have explosion 2, which is a second sound, which could be made up of a bunch of different tracks, or maybe even the same tracks where we've tweaked out the pitch or something and the volumes. But then down here in the queue, we could just call the queue explosion. And then we could have 2 different explosions actually set up inside the queue, and then with play probability of 50% and 50%.
Or if you had a game world set up and you wanted to create ambience noise in the background, you could grab a few different wave files, one of maybe birds singing, another of wind, another of water, and then put those all into different sounds. Then from a queue, have it set up so that it will randomly decide which one to play. Mm-hmm. So that every time ambience is triggered, it's a different actual kind of ambience, birds or wind or something else.
Right. I like the explosion one better.
Well, explosions aren't
different dynamic explosions. I wouldn't want to be walking out in the middle of a field and suddenly I hear water. Where'd the water come from? Be very confusing. Oh, but anyways, you guys get the idea. Go ahead and set up a second sound in there real quick.
Okay.
So we'll drag that's perfect. And then let's go ahead and add beep 4 down to the queue, just so that they can see now we've got a 50-50. And if Logan plays this, you'll see how it's going to go back and forth between the 2 different sounds. Simple enough.
Notice, however, that it seems to be going in sequence and not random.
That's
because the random type we're using is with no immediate repeats. There's only 2 things, so it's never going to look random. We could turn it to a true random, and now as we play the queue...
Exactly.
So now we get an actual random.
But in our case, we're not looking for a queue to contain multiple sounds that could be randomly played. Instead, we're just looking for a single queue to represent a single beep.
Right, so of course we could go back in here and delete one of these out. But there's another thing that can help speed up setup of a lot of wave files. If we wanted to, let me begin by deleting out this queue entirely. If we wanted to, we could take a wave sample and drag that directly to the queue pane. And let me do that with 3, or let's see which one hasn't been
Actually,
used.
go ahead and kill out beep 1 and beep 4 in the. There we go. Yeah, watch this, guys. This is where things get really easy.
So watch this. We could take a wave, drag it directly to the queue pane, drop it in. Now we have the queue created. We have the sound created associated with the wave, and the sound also associated with the queue. So everything, the entire chain has been set up here. And you can also select multiple waves at once and drag them all in, and then have everything set up very quickly. So if you're right off the bat knowing that you had these 4 sounds in the sequencing app and you wanted them to all be 4 different waves, you wanted them playable as soon as possible, then simply load up Exact, make a wave bank, a sound bank, put all of the waves into the queue pane, and you're all set. You're ready to go.
All right, beautiful. So now that we've got this done, what do we need to do to bridge the gap between this and the world of XNA?
Well, we need to save our project file from Exact and then go back into Visual Studio and import that using the content pipeline.
Okay.
So let's go to File, Save Project. Now you'll notice that I'm currently up within the project folder for the sequence test. I'm actually already up under the sounds folder, which is convenient. And we are saving the file as a project file. A .xap file is fine. And what I'm going to name this is audio. The exact name is up to you for however you want to store this. Just keep in mind that this name will be needed later inside of XNA. So we'll hit save to this project as audio. Now we'll go back to Visual Studio and go to that sounds folder I created earlier. We'll right click on it and we'll say add existing item. For here we'll go into the sounds folder itself, switch over to content pipeline files, and load in the audio.xap or exact project file. So with that added in, this hasn't actually done anything yet. What this project file describes is where to get the wave data from and how to interpret it. the content pipeline processors will use this at build time in order to import everything. And I can show this by bringing the project folder back up, jumping up and going into the output folder, so into bin x86 debug. Here we have the sequence test app, our textures folder, and nothing else. Now if I go back to Visual Studio with this audio project loaded and press F6 to build, we'll give it a second until the build finishes, go back to the output folder and we have this new sounds folder. If we go into the sounds folder, we have 3 new files. We have an XGS, which is an exact global settings file, and its name is dependent on whatever our project name was. In this case, it's audio. Now, alongside that, we have 2 other files. We have a sound bank and a wave bank file. And these, of course, corresponding to the wave bank and sound bank we created earlier inside of Exact. And these files got generated at build time. Now, keep in mind the actual names, the actual file names of these, as these will become important when we need to get these associated in our project itself, in the code.
Okay.
So with that, I think we're ready to go back into code and write a small sound helper that will let us get these audio samples and sounds loaded in and usable at runtime. So back inside of our project, I'm going to add a new class. I'm going to add a sound helper class. So I'll add in sound helper. And the reason I'm adding this as a separate class is just to keep all of the sound relevant things out of the main code. It makes it cleaner and easier to read. Everything we're about to type could, of course, be put in the main class if you wanted. So here is our new sound helper class. Let me begin by taking off the class's subnamespace, and we shouldn't need text or collections in here. I do need to add a reference or a using for xna.framework.audio. So I'll add in using Microsoft.xna.framework.audio. Alright, now the sound helper class I'm going to make static. So this will be a static class sound helper. And now we need to add 4 fields. 3 of them will be used to hold relevant objects that work with the audio data itself and an audio engine. And we'll also need to make some way of holding the names of those cues. Because remember, we had some cues named beep 1 through 4. We need to reference them by their actual textual string name. So let's begin with the fields for the audio itself. So I'm going to make all these static fields, of course, because we're in a static class. The first is going to be the audio engine. So we'll define a static audio engine, which we'll call audio engine. Next, we'll define a static wave bank, and we'll call that wave bank. And finally, we'll define a static sound bank, which we'll call sound bank. Now, some of these should look familiar. We had just taken a look at wave banks inside of Exact. We took a look at the resulting file from the wave and sound banks, and now we have actual objects inside of XNA that allow us to work with those files. So one more field we need to create is an array of textual names that we can use to refer to the cues. To do this, I'm going to make a static string array, which I'll call sounds. Alright, now let's put together an implementation for the sound helper itself. First, let's put in an initialize method, because we need to have the audio engine set up before we start trying to use this as the game is running. So I'll put in a public static method called initialize, and the return type is going to be void. So public static void initialize. This one.
Yeah, looks good.
Okay, good. As for some reason, I was just kicking off the spelling error thing, which was working yesterday, but apparently not today. All right, but inside of initialize, we need to create an audio engine, a wave bank, and a sound bank. So we'll begin with the audio engine. We'll set that equal to a new instance of audio engine. And that audio engine is going to need a settings file. That is that XGS file, audio.xgs that we were looking at a moment ago. And it needs to follow the same path rules as textures. If you remember from earlier lessons, textures end up in an actual textures output folder that have their relevant items in them. Now, of course, instead of textures, this is going to be sounds, and I'll throw in our literal string characters so we can put in characters instead of escape sequences. So this is going to be under the sounds folder, and the settings file was called audio.xgs. Now, unlike textures, the audio data does require having the extension. You have to load the actual file, whereas a texture would have just been audio or whatever the name was. Mm-hmm. So keep that in mind, because that could be very easy to change up since we're so used to doing the content load and all that.
Right.
All right, that has the audio engine created. Next, we need to create the wave bank. So we'll say that our wave bank reference is equal to a new instance of wave bank. Now, wave bank is going to need two things. It needs to have a reference to the audio engine itself, and it needs to have a wave bank file name. Now, of course, audio engine is from the audio engine field, and the wave bank file name is going to be, if you remember in that folder there was a wavebank dot, I think it was XWB.
Mm-hmm.
So let's put in the string for sounds / wavebank dot XWB. And if I typed any of these names wrong, we'll be quick to get an exception as soon as we run the code. But this just leaves our sound bank now. So let's create an instance of sound bank stored in our reference. So new sound bank, and again we need to take in a reference to the audio engine, and then we need to feed it a file name. So we'll give it sounds, and then sound bank dot, what is this, XSB. Alright, so that is all of the audio related elements. Now let me also set up and initialize our sounds array. And we have sounds equal to a new string array, and I'll define all of the elements here. First element will be the string beep1, beep2, beep3, and beep4. Those, of course, relating to each of the cue names that we had back in exact. And that should take care of initialize. The next thing I'm going to add is an update method to our sound helper class. This will be a public static void update. And the reason I need an update method is the audio engine itself needs to be periodically updated. So what we'll do is we'll make a call here to audioengine.update. Because if you'll notice, we haven't defined any of these as public, so we wouldn't be able to access the audio engine itself outside of Sound Helper. So we need some way to reach into the Sound Helper and tell it to update the audio engine. And this is a method call, so we need to have parentheses after that. All right, one last method that we want to add, and this will be the most important from outside of the Sound Helper, and that is the playSound method. So we'll put down a public static void play sound. And for play sound, I want to take in an index of what sound to play. I'm going to call this the pitch index, because that's what differs from sound to sound. But in our case, this will conveniently match the index of what direction was pressed, because we have 4 sounds, we have 4 cues, and we also have 4 directions, so those will nicely match up. Now inside of play sound, we want to take a look at the sound bank itself, because the sound bank is what's going to have the functionality necessary for playing sounds, more specifically playing cues. The 2 main things we can use inside of here are getCue, if we need to get a reference to a cue in order to do any additional setup before playing, or we can directly fire off a cue from here without having to hold a reference to the cue itself. So we'll use playCue, and playCue takes in a string to refer to a cue by name. Now we have all of those names preloaded into a sounds array, so I'll plug in sounds sub whatever pitch index was. And that should play the appropriate sound for whatever direction index we feed in.
Right.
And that should take care of the Sound Helper class. Let me build to make sure that there's no errors introduced, and the build has succeeded.
Nice.
So let's go back to the game class and tie all of this in. The first thing I'll do inside of the game class is go up to our initialize method. And then maybe near the beginning we could call, right after the sprite batch, we could say soundhelper.initialize. And that'll get all of our audio data loaded in and get the array set up. Then inside of update, we need to remember to call or make the call to update. So right after input helper, I'll put in a call to soundHelper.update. So now all the inner workings of the engine should get created and then updated. Now we can simply call the playSound method at will. Now we want playSound to be called from within the pulse method, because pulse was meant to be the generic cause pressed effect for the directions, for the buttons. So right after we make a call to the buttons pulse, we'll make a call to soundHelper.playSound. And then we'll feed in button index. And that should be it.
Yeah, it's really that easy.
So let's run the game now. And there we go.
Very nice. So addicting. Okay, that's pretty much it, guys. We've taken a look at the exact tool and the auditioning utility and how we can get some simple WAV files brought in, set up, and then through the content pipeline and used in our XNA game. And with that, you should now have everything you need to create the Memory Master game. So that is your assignment. I hope to see some Memory Master games show up in the classroom from students that get this knocked out. And with that, that wraps up this section. Thanks a lot.